Hi, thanks for joining me today as I discuss Lustre 215 and upcoming features. As you can see, there's quite a number of features planned for 215 and future releases. 215 feature freeze has already happened, and we're in the process of finalizing various smaller fixes and doing extended testing on this release. The features listed for 216 are already well underway in terms of implementation, and they're waiting for the next feature landing window to open. 217, starting off with LNet, there's a number of improvements in this area above and beyond the normal bug fixing. One of the important ones for many users is optimization for TCP sockets so that it will better leverage the ability of multiple cores in a client and server to use high bandwidth connections. Cons per peer has been present for O2IB LND for some time, mostly to work with OPA networks. But on SOC LND, we also need to leverage multiple cores and multiple connections in order to get the maximum bandwidth. The other big improvement for LNet is the LNet network selection policy. This allows admin to configure policies in terms of which interfaces are being used and how best to access network interfaces from various cores on the client. In 216, we're hoping to improve the configuration of LNet network interfaces so that Lustre configuration logs themselves don't have to store the network IDs. And that will simplify upgrades and changing network interfaces and such. We'll delegate all of this configuration to LNet itself. The other major feature for LNet in 216 is IPv6. This is work underway mostly by Neil Brown from SUSE. There's quite a number of patches for IPv6, as well as protocol changes on the network side. And a number of these patches have already landed in 215, but it's an ongoing process and should be finished by 216. On the D&E front, there's actually been quite a lot of work done in this release in order to improve the usability of the D&E feature, so multiple MDTs. Firstly, parallel file renames within a single directory are now allowed. Previously, there was the BFL, the big FID lock, was needed to lock the entire file system for any rename. And now in the common case of renames within a single directory, we can lock only the parent directory. And so that allows concurrent renames in different subdirectories. The biggest feature is D&E space balancing across MDTs. And so essentially what that is, allowing regular application makedir to create subdirectories on MDTs that have more free space than others. And so this is totally transparent to applications and allows better usage of multiple MDTs. There's no need for manual MDT selection for applications or users, and it helps you utilize all of the space and performance of the various MDTs. At the top of the file system, there's typically a desire to balance across MDTs pretty strongly. So there's round robin MDT selection by default. And as well, if the MDTs are significantly imbalanced, the MDT that has the most free space will prefer to be used. But in order to avoid too much performance impact, subdirectories prefer to stay on the parent directory if the space is balanced. And this, and because this is an issue that people have had quite a bit, the MDT space balancing is enabled by default in 215. And so it will try to keep the space usage within about 5% across the MDTs. And similar to OST space balancing, It's possible that if you have like one very large directory, as with very large files, that may cause the space usage to be skewed, but it tries to correct this over time. It is possible to disable the automatic space balancing if you need it, and it isn't doing the things the way you want it to be. In 2.16, we've already worked on a couple of smaller changes to also help D&E be more usable. Firstly, the ability to migrate a single directory using the -D option allows you to specify, just one directory that you want to migrate or restripe without having to, move an entire directory tree at one time. As well, it's possible to have the client select the best MDT to migrate a directory onto, rather than having to manually specify which MDT to use. Another big feature coming in 2.14 and 2.15 is data encryption. In 2.14, we had data encryption for the OST objects, and new in 2.15 is encryption of the file names. And so there was some, semi-complicated work done here to allow file name encryption to work properly with D&E, with hashed file names and such across multiple MDTs. And similarly, since this is based on fscrypt in the upstream kernel, the same sort of features and limitations apply. Firstly, the file names are, displayed in a, essentially random garbage if you don't have the directory key. But as a user administrator, you can still delete files if you don't have the key. So if you lose a key, you can clean up that directory tree. The file name encryption does not protect inode attributes such as file size, ownership, and such, or the structure of the directory tree. There is a bit of, the file size is rounded up to the next block to protect the size a little bit, but that's it. The other thing that's been added in 2.15 is that you can migrate and mirror encrypted files without having the key. And that's important for tools, HSM or tiering that needs to manage space, but you don't want to give the tools, every copy tool shouldn't have to have a global decryption key for all of the files in the file system. It can do the space balancing without having any specific knowledge of the content of the files. In 2.16, we're going to be looking at improving the performance somewhat for encryption. You can have pretty decent performance, but it is a bit CPU limited on the client because the clients do all of the encryption. But if you have enough clients today, 8 or 10, you can saturate the server because clients typically have lots of CPU, but we'd like to make this more efficient. Other usability improvements have been going in. These are a number of small various things in terms of APIs. fallocate started off in 2.14. SQL seek data, statfs for project directories is quite useful. Statx is a new API to reduce the overhead of getting attributes. So if you do ls, without specifying ls minus L and you don't need the size, it doesn't fetch the size from the OSTs, which is, an improvement. There's open caching on the client automatically for files that are opened repeatedly, large ACLs, hole punching for free space, and fallocate for DOM files. As well, the old llstat and odstat utilities have been improved so that you can use them more easily on the client, essentially specifying the same stats file names as you would for getParam and setParam. And they're not intended to be cluster-wide monitoring tools, but it does simplify if you just need to grab some stats on a client or a server. They're always installed and easily used. In 2.16, and 2.15, of course, for many releases, there's ongoing kernel cleanups from James Simmons and Neil Brown, and there's a whole presentation on that, so I not getting into any details. Another area that's been under active development in the code is the Lustre changelog. And we've worked on a number of improvements here to simplify usability and just to make the code, a lot easier for administrators to manage without getting into trouble. Firstly, there's named changelog users, and that allows admins and applications to specify a short string that allows identifying the changelog user. Prior to this, there'd just be a short name like CL1, CL2, CL3, etc. That doesn't really give you much information about, which application is using that changelog, is it still in use, etc. And so now you can specify, a name, for instance, like Robinhood. It could use RBH to identify its changelog users on the different MDTs. And that allows the application to identify, which changelog it should use without manual configuration from the admin. And it allows, identifying if there's stale changelog users around, they can be deregistered proactively rather than worrying about, in case you don't want to disrupt the operation of an application. Similarly, the changelog per user mask allows specifying on a per changelog user basis which records are of interest to that application. Prior to this, there was a single global changelog mask that specified all of the different record types that need to be recorded in the changelog. And typically this was left at the default, which is recording almost all of the changelog types. And it was difficult to change this because you didn't know if applications are added or removed, if it was safe to expand or contract the mask. And so by specifying this on a per application basis, you can limit it only to those users that are, actively processing the changelogs, and it will dynamically change when, changelog users are added and removed to the system. And that reduces overhead, what gets recorded to disk, what needs to be processed later on. It's an improvement all around. For upgrades, if a specific changelog user doesn't have a registered mask, the global changelog mask still gets used for those users. But if all of the changelog users have a registered mask, then only the minimum subset gets used. Another interesting patch that's quite useful from HPE in this area is to improve the cancellation of changelog records. Previously, they were being, when a user was being deregistered, forgotten a changelog user, the records were being cleared on a per record basis, and that might take hours or days if there's, millions or billions of records that were left behind. And now these are being cleaned up on whole file basis, which, just deletes the internal changelog file that holds the specified records. And so this is about 100 times speed up, means that you can, clean up a billion, record changelog in, 5 minutes or so. The other area that's just starting to be fixed is idle changelog deregistration, but it currently only deregisters idle changelog users if the changelog itself is very full. And that isn't really practical in most cases because you hit other constraints first. And so this is being changed over to deregister idle users after specific time limits or specific large number of records are going unprocessed by that user. with the named users and masks, etc. This allows applications, if their changelog user was deregistered, they can easily determine that and reconnect. And it avoids, a fairly common situation where a changelog user was registered for some test and forgotten, and it may consume all of the space on the MDT, or run out of capacity to store changelogs. As well, there's a number of improvements for the backend OSD interfaces to the file system. I previously mentioned that there's a parallel E2FSCK that significantly improves the pass 1 and pass 5. In 2.16, we've started work for parallel E2FSCK on pass 2 for OSTs. Pass 2 used to be only 7% of the runtime. Now it's 70%, and so that's quite a bit of room for optimization. For MDTs, pass 2 is, the directory scanning is a substantial portion of the time spent. ZFS has had a number of improvements. That would be, it's a whole presentation or two by itself. But there's a number of, desirable features that have gone into ZFS 2.0 and 2.1, in particular the DRAID VDEVs, which was originally based on work that we did long ago at Intel, has been finished off by Livermore and HPE, the 2.1 release. As well, on the LDiskFS front, there's improvements in the upstream ext4 for MBALIC and discard, right, for trim of flash storage. And so we're working on backporting those into the Lustre LDiskFS patch series, so that we can get those improvements, which are very important for large OSTs. As well, there's some work at the OST level to improve the situation with very large numbers of OST objects on one large OST. How that is working between OST and MDTs. We can improve that. On the client side, there's been quite a bit of work to improve the performance of single clients. In the past, it used to be that individual client performance was less important than it is today, because with the increasing core counts and independent workloads instead of cluster-wide workloads, the single client performance and even single threaded performance is getting more and more critical. So in 2.15, a big new feature is GPU Direct RDMA. So that allows on NVIDIA GPUs for the I/O to bypass the CPU and the PCI bridges, and instead you can transfer RDMA directly from InfiniBand HCAs directly into the GPU memory. And so that both can speed up performance in some workloads, but more importantly, it offloads a lot of data handling from the CPUs, which are often a constrained resource in large GPU systems like the A100. As well, Patrick Farrell has been hard at work optimizing direct I/O performance, and he's had some very substantial improvements there, which I won't get into because he's doing a whole presentation on that himself. In 2.16, there's some early work being done for optimizing the NID binding on the server side, and that impacts, if only a single client is writing to a multi-core or multi-CPT server. Right now, it's bound only to a single core on the server, but we'd like to, allow a single client, that may have multiple cores and multiple network interfaces itself to more fully utilize server resources. But we have to balance that against, having huge numbers of clients still be efficiently handled on the server. One of the features well underway for 2.16 is the batched cross-directory stat ahead. And essentially this is combining a number of components to provide early usage of some features that are going to be used by the write-back caching in the future. Firstly, there's the ability to batch multiple updates into a single RPC over the network. And that allows, the client to more efficiently send large numbers of operations to the MDS when, it has to flush cache or, fetch a lot of attributes at once. You can do that in a single network transfer and get all the responses back in a single reply. And this optimizes both the network round trip as well as the server-side handling of those requests. And this is initially being used in batched stat ahead, which we already have stat ahead for ls-l and find and similar directory plus stat workloads. But those send their RPC requests one at a time to the MDS. And the batched stat ahead sends, multiple requests at once. And what's interesting at this point is the enhancement of stat ahead mechanism to allow cross-directory operations by having more sophisticated pattern matching. And in the stat ahead today, we only detect, readdir plus stat workloads that are following the readdir order. And with improvements that have already been developed, this can detect alphanumeric ordered traversal plus, let's say file name plus digits at the end, right? Which is typical file 1, file 2, file 3, etc. And more interestingly, there's the breadth first search and the depth first search. So when you hit directories in a readdir traversal, it will see if you descend, the process descends into the directory. So we'll do a depth first search and traversal, or if you process all of the entries in a single directory, it will scan ahead across the directories and optimize directory prefetch, even for directories that the application hasn't accessed yet. And so this can really improve ls-l and similar type workloads. The last major feature that's planned for 2.16 is the client metadata write-back cache. Now, this has been under development for a year or more already, and will provide a very significant improvement to metadata operations from a single client. Essentially, the main benefit is that it avoids round trip times to the MDS for file type operations, create, make dir, unlink, etc. And we've seen significant improvements here for normal workloads, untar, make, etc. And I'm really looking forward to this one getting included into the next release. There is already a presentation by Yinjin Qian and Li Si, and so they'll be discussing this in detail, so I won't be going into it very much here, except to say that I think that this will really help a number of important workloads. Thank you all for attending, and I hopefully can answer your questions if you have any. Thank you. Bye.